Hello everyone and welcome. This video demonstrates how to use the Map Block tool to create solid mesh in ANSA. The Map Block tool is a highly effective feature designed for creating hexahedral meshes by dividing a 3D domain into structured blocks. It's particularly effective for geometries that can be broken down into simpler, more regular shapes. The Map Block tool has three key functions. First, division of geometries. It allows you to split a complex model into smaller, manageable subblocks. This makes the process of creating high-quality hexahedral meshes much simpler. Second, mapping. The tool automatically maps the mesh across these subblocks, ensuring smooth transitions and continuity. And finally, user control. It enables you to adjust parameters such as the number of divisions, edge alignment, and node distribution, so you can fine-tune the mesh for the best possible results. By using the Map Block tool, you can handle complex geometries with greater efficiency while maintaining precision and quality in your mesh design. The prerequisites for using the Map Block function include: first, clean, gap-free geometry without overlaps or intersections for smooth meshing. Second, closed, watertight volumes, as open edges or faces will cause failure. Third, simplified geometries decomposed into manageable subvolumes. And finally, matching topology on opposite faces for quad-only meshing in transition areas. By meeting these prerequisites, the Map Block function can generate structured hexahedral meshes effectively. The part of the model presented here is composed of two different shaped areas: a cylindrical and an orthogonal section. Due to the fact that the volume here is only one, applying the Map Block function will require further decomposition of the part into two separate smaller closed volumes in order the mesh to be created. The second part of the model is a bit more complex. This time, more decomposition steps will be needed to ensure it can be properly mapped and meshed. On the right you can see the discrete volumes the part can be divided into, creating simpler subvolumes that enable the function to work effectively. We will demonstrate how to generate a structured mesh on the previous model using the Map Block function. Working on the first part, apply our function and keep visible only the bottom left piece. Map Block function, as all functionalities, automatically reads the global parameters and quality criteria for generating the mesh. For the desired target element length of the meshing, we can either set the target element length direct to the global settings or copy a meshing scenario to them from the batch mesh. Open the batch mesh and copy the first mesh scenario to the global settings. Activate the Define Map Block function in the Volume Mesh ribbon tab in the Structured section. You can see in the Parameters window that the target length is set to 6, as copied from the mesh scenario. Select the part with the left mouse button from the drawing area and confirm with the middle click. The draw mode automatically switches to map and draws the faces according to their status. In this case, the part is defined as non-mappable. The part must be decomposed in smaller subvolumes. Press OK and a new ribbon tab is enabled, containing the decomposition group, which provides functions to assist decomposing a component. We can see that if we create a face in the base of the cylinder, two discrete simple closed volumes will be created. Activate the Geometry Fill function, click on the Loop tool and select the perimeter to create a circular face. Middle click to confirm. The face is created and the Map Block status is switched to Need Update. Right-click in the Need Update section and select Update. After any modification on the recognized volume, an update is needed in order to decide its status again. After the update is completed, the Map Block status changes to Ready to Mesh. However, you may notice the inclination of the generated surface mesh. To address this and enhance the mesh flow, some normal cuts are necessary. Activate the Direct Edit Geometry function and make the cuts by dragging the nodes to create a cube. Note that the map block status will revert to Need Update. Right-click on the Need Update section and select Update. Once the update is completed, the map block status will change to Ready to Mesh. Right-click to the Ready to Mesh section and select Mesh. Deactivate the faces and see the generated structured mesh. Component is meshed with hexas and pentas. Activate the faces again, enable the caps on the legend and right-click on the Show Only. You can see the boundary surfaces of each subvolume that map block has recognized and the direction of the mesh flow. These were used as the boundaries for the generation of the structured mesh. Click on the All function from the focus buttons to bring back to visible all parts and uncheck the caps from the legend. Now we will proceed with applying map block function to the second part. Apply or function and keep visible only the part without mesh. Activate the map block function. In the parameters window, the target length is set to 6 as copied from the meshing scenario in the beginning. Click to the part to select it and middle-click to confirm. Map block creates a temporary mesh as an intermediate step to detect and define the volumes. The part needs further decomposition. Click OK in the warning window. Select the Auto Split function from the Decompose ribbon tab. Auto Split automatically identifies and applies strategic splits to the part, dividing it into smaller, more manageable subblocks where possible. It creates new faces in a specified direction, guided by a user-defined vector, forming closed subvolumes. In our case, that map block is unable to recognize the single composite volume. Splits along the X direction in the upper part can create simpler rectangular and cylindrical subvolumes. In the Parameters window, enter the value 1 in the first box in the Vector section to set the split direction along the X-axis. Click Preview. As you can see, all the proposed splits are on the X-axis, perpendicular to the YZ plane. Click OK to confirm the splits. Auto Split function updates the status automatically. The upper part status changes to Ready to Mesh. For the lower part, we will start with isolating the two holes that stand out from the base of the part. In the Decompose tab, use the Fill function to create a new face, and select the cones forming the perimeter of the volume to be isolated. Confirm with middle mouse button and accept the surface to be created. Repeat the same process on the second hole as well. The newly created faces are closing the holes. Activate the Trim function, select the two holes to be opened and middle-click to delete the internal faces. Update the model. The model is now green and characterized as Ready to Mesh. Activate the cap's visibility from the legend to see the direction of the mesh flow that will be generated. Uncheck the caps and see in the back side the annular and the 3 rectangular volumes that AutoSplit has created. Right-click to the Ready to Mesh section and select Mesh. Deactivate the face's visibility. Component is meshed with hexas and pentas. Activate the visibility of the faces and click View All to restore visibility of the entire meshed model. This is the final result. The user has the ability to remesh the part either by entering new parameters directly in the global settings, or by copying another scenario in them from the batch mesh, and running the map block again. Map block can be reapplied either before meshing, when the part is characterized as ready to mesh, or after the part has been meshed, provided that volumes have been deleted. On the right, you can see the first part remeshed with a target element length of 10 mm. Additionally, different treatments can be applied to the meshing to improve mesh flow. For example, in the second part, since the 3D holes recognition feature is enabled, and the setup for 3D hole treatments is activated, zones can be generated. 3D hole treatments activation can be set either directly in the global settings, or in the meshing scenario, and the scenario then to be copied to the global settings. Around the holes, zones of a defined width of 4 and 6 mm are created, improving the mesh flow. Thank you for watching.